Okay, so today I am going to discuss another CSIR NET PYQ. It's a 2021 PYQ and it's from quantum mechanics. Okay, so in this problem, first pause this video and read this problem. Give it a try by yourself. The correct option will be B, I guess, maybe. Okay, so try it yourself, then look at the solution. Okay. So they say the two-state system evolves under the action of Hamiltonian. This is the form of Hamiltonian they give. Okay, so I will explain a little bit about this form. Okay, sometimes it may be confusing for someone. Okay, so I will explain it a little bit about this. Okay, where A and B are two orthonormal states. Also note this point because normally we ignore these points. Okay, but maybe sometime it's very important, and especially for this problem I will give you a counter example where this if these two states are not orthonormal, then what will happen. Okay, and these states transform to one another under parity, so they give given a parity operator which whose action on the both states are given like this. Okay, so these are the action of parity operators given like this. Okay, so these are two operators and their actions are given like this. They are orthonormal states. And if at time t is equal to 0, the system is in a state with definite parity p is equal to 1. So p has some, or p is a operator, it has some eigenvalues. So they are saying that the eigenvalue 1, the corresponding eigenstate of eigenvalue 1, it is the initial state. Okay, so the earliest time t at which the probability of finding the system in a state p is equal to -1. Okay, so they already have given. Okay, so p has two eigenvalues 1 and -1. So initially the state is p is equal to 1. So you have to time evolve the initial state, to go through the time evolution of the initial state, and finally have to answer the question that what is the probability, what is the shortest time in which the state will flip to p is equal to 1 to p is equal to -1. Okay, so these are the all the informations given in the question. A lot of informations are given. Okay, so first let me tell a little bit about the Hamiltonian. Okay, so it is given like in this form: a plus e naught plus delta b. Okay, so I guess this is the form. Yeah, so this form is actually sometimes called a density matrix configuration. Okay, somebody of you maybe knows this configuration, density matrix configuration of the Hamiltonian. Okay, so this is the density matrix, and what is I mean, don't go with this. What is density matrix and what is what? So let me give you something. Let suppose you are operating H with A. Okay, so what is h of a? H of a, if you, sorry, this is this. Okay, so if you act on a in this side, a in this side, you will get h of a, right? Now b, they are orthonormal states, so this will give you 0, right? So only you survive with e naught a, right? Now again act with a bra a on left, from the left side, so you will be getting simply A naught, E naught, because A and A B are orthonormal states, right? So similarly, your BHB is similarly E naught plus delta, right? So these are the two informations basically encoded in this data. Encoded in this data, these two information basically encoded in this data. Okay, so suppose let me give you an example. Suppose they give an state which is like ab plus e2 ba, right? Suppose they have given this type of configuration in the question, then then your ahb is what? If you act a b from the right, this will give you a 1, but this will give you a 0, so it will be 1. And if you act b from the left and a from the right, then you will get e2. So suppose this will be the Hamiltonian, then this will be the two informations. Now how to construct a matrix from this two this informations? So for any operator, if you most probably know this, that if you construct Lx operator, Ly operator, you first have to construct L plus and L minus operator, and you construct these things from 1 1 1 0 1 minus 1 state, right? So it's something like h cross by root 2 0 1 0 1 0 1 0 1 0, something like this. Probably I forgot some things, but okay. So this kind of things, you know, that how to construct a matrix form of the operator from the given information. So basically for this configuration, so it is a b a and bb, right? So for our given question, the matrix form of the operator is Hamiltonian is E naught 0 0 E naught plus delta. So this is the Hamiltonian basically in the matrix form. For this Hamiltonian which I wrote here, so for this Hamiltonian the matrix form is AA is 0, AB is E1, BA is E2 and 0. Okay. So don't forget about this. I just gave an example about how to construct the matrix from this kind of given data. Okay. So yeah, so that is fine. So H is your this E naught 0 0 E0 plus delta. And similarly, your parity operator is what? PA is, they already mentioned that parity operators act like this. Okay. They will flip the states. So if you act a from the right side, this will give you this and is equal to 1, right? And if you act a b from the right side here, you will get a b from the left side here, b from the left side here, and you will get this will give you 1. So what is the operator form of p? It's simply aa is 0, ab is 1, ba is 1, and again bb is 0. So this is the p operator, parity operator in matrix form, and it is nothing but your sigma x matrix, right? If you recall from the Pauli matrix, this is the sigma x matrix, just like the sigma x matrix, exactly that. Okay. So what are the eigenvalues? You already know that its eigenvalue is plus 1 and minus 1, and it's already given in the question. Okay. And if you recall, if you remember, what is the eigenvector for the plus 1 state? It will be in the normalized form. You can normalize it. You don't, if you don't want to normalize, then don't normalize it at the end of the calculation. Okay, so this is the eigenvector for plus 1. Okay, this is the eigenvector for plus 1, and this is the eigenvector for minus 1, right? 1 by root 2 1 minus 1. If you forgot this two, you can immediately calculate it very quickly. Okay, I think I don't need to do this. You can calculate it. Okay. Similarly, for the Hamiltonian, the eigenvalues are E naught and E naught plus delta. Okay, E naught and E naught plus delta. And for the E naught, the eigenvector is 1 0, and for E naught plus this is already a diagonal matrix, right? Only the diagonal entry is there, so it is already diagonalized, so you don't need to bother about what is the eigenvectors. It's simply 1 0 and 0 1, right? For any diagonal matrix. So these are the two eigenvectors for H, these are the two eigenvectors for parity operator. And now they have said that psi at t is equal to 0 is this eigenvector corresponding to p is equal to plus 1, right? So 1 by root 2 1 1, right? Now you have to time evolve this. So to time evolve this, you have to split this eigenstates into the eigenstates of the Hamiltonian. So make this 1 by root 2 1 0 plus 1 by root 2 0 1. Now this 1 0 is the eigenstates of Hamiltonian, 0 1 is the eigenstate of the Hamiltonian. Now you can time evolve this. Okay. So psi at t is equal to t is simply 1 by root 2 1 0 e to the power minus I e 0 t by h cross plus 1 by root 2 0 1 e to the power minus I E0 plus delta. Remember the 0 1 has an energy eigenvalue E0 plus delta. Right? E0 plus delta t by h cross. So you get your psi at t is equal to t. And now they are telling you have to calculate some probability. No, not probability, the minimum time after which the state will evolve to p is equal to minus 1. So what is the eigenvalue for p is equal to minus 1? Eigenstate for p is equal to minus 1, right? Eigenstate is this. your minus 1 eigenvector. Yes, so it is 1 by root 2 1 minus 1. So when the state will psi t is equal to t flip to this minus 1 state, then the probability of getting this state in minus 1 state is just exactly 1. So the probability of psi is equal to the minus 1 state is exactly the taking the inner product of minus 1 state with psi at t is equal to t, right? So this will be the probability, and this should be is equal to 1 because it will flip to this minus 1 state. So the probability of getting this state in minus 1 state is exactly 1. Okay, so you have done this many times in quantum mechanics. So this is your 1 by root 2 1 minus 1, and your psi is already written in this previous page. You have to take just the inner product. Okay, so you will get 1 by 2 e to the power minus I e naught t by h cross minus the, because of this minus sign it will flip the sign. Okay, so if you take the inner product, no complicated calculation, just simple calculation, you can do this. Okay, so mod of this squared is equal to 1, right? Now you can eliminate this e to the power minus e naught t by h plus from the both side, because mod of e to the power some ix kind of thing is always is equal to 1. It is a purely mod 1 imaginary part. Okay, so you can get it outside from the mod and make it is equal to mod of this is equal to 1, right? So inside the bracket what you left with 1 minus e to the power minus, so there is a iota here. Okay, I delta t by h cross by 2 square is equal to 1. Okay, now sometime you may be confused about what can I do with this, so I will give you a simple trick. Okay, so take this e to the power I minus I delta t by 2 h cross outside the bracket, and then you can write it as e to the power I delta t by 2 h cross minus e to the power minus I delta t by 2 h cross. Just rearrange this thing with this thing. Okay, so taking something out of the bracket and the remaining thing will be like this. So what is the advantage of this? This will become a sine term. Okay, mod square is equal to 1, right? So this mod of this is equal to 1 into the power ix type of form. So you will simply get sine square delta t by 2 h cross. There will be a 2 I of course, but mod of I is 1, so nothing matter if you multiply and divide it by I is equal to 1, right? And what is the minimum value of this sine? If you make it, you have to make it 1, so you can make it sine square 2n plus 1 pi by 2, right? Now you have to choose the minimum value, so you put n is equal to 0, right? Then you will get the minimum time. Okay, so delta t by 2 h cross is equal to 2n plus 1 pi by 2, right? Cancel this 2, then your t is equal to h cross pi by delta into 2n plus 1. Now you have to tell us the minimum value, so that select n is equal to 0, because at n is equal to 0 t will be t minimum, right? So t minimum is equal to pi h cross by delta. Okay, so the problem has nothing much to do, just do you have to carefully make this operator construction from this given data. Okay, so this is the given data and sometimes it may be confusing, so just showed you that how to construct the matrix form of the operator from this kind of given data. Okay, so yeah, so I think that's it for today, and thank you.